So the second video from section 3 is trying to take parametric equations and getting rid of that variable of t, getting it in our more familiar format of y in terms of x, or at least comparing x and y without having that third variable. So I just have three quick examples. Some are a little bit more obvious than others. If our first parametric equation was x equals t plus 1 and y equals 2 times t, and then don't worry too much about this interval right here, but just thinking about the equations, one thing we might want to do is think about what the graph of the parametric equation looks like. So I have that set up in Sketchpad. The only difference up here is instead of t we have theta, and then I can kind of put in a different interval for theta or for t down here. It might be a little hard to see on your screen, but basically I'm just going to hit advance and it's going to show you what the graph looks like. So it's going to look something like this, and you can see that as t gets bigger, the points that we're plotting is just a horizontal line. So if we go back to our notes and we go through the process, I should expect just a line that has a positive slope. Looks like the y-intercept might be something like -2. So let's go back to our notes here. There we go. So what should we try and do? The first thing I'd probably do is take this equation right here and I would rearrange it. I would solve for t. So basically if I brought that 1 to the other side, I would have t would equal x minus 1. There we go. Okay. So I just took the first equation there and rearranged it. And now I'm just going to take the y equals 2t. And instead of a t, I'm going to put in x minus 1. And I could distribute the 2 if I wanted to, and I would end up with 2x minus 2. Which, if we go back to the picture that we had on Sketchpad, it kind of looks like that, right? This here, it looks like it could have a slope of 2 and a y-intercept of -2. Okay, if we move on to our second example. Let me get my mouse there. There we go. Okay, second example. Same sort of setup. It's x equals 3 times t, y equals t squared minus 2. We're really only interested in this interval, but again, for this sort of a setup, I'm not super worried about the interval there. Go back to Sketchpad, look at our second example. Again, instead of t's, we just have thetas, but it's the same sort of idea. And now this actually is limited to -2 and +3. So again, I hit advance. It's calculating all these x and y values based on the t value that we have. And you see that we should expect some sort of a parabola with maybe a shift down of some sort. But it does look like it's kind of evenly centered around the y-axis. So we go back to this, and I'd kind of go through the same work. I would take the equation that I have for x equals 3 times t. I would divide both sides by 3, and in doing so I get t equals 1/3 x, or x over 3, however you want to write that. And then I go to my equation for y, and instead of a t being squared, I'm going to have 1/3x being squared, and then don't forget the -2 at the end. Okay, and then if I actually go through and I square that, we are allowed to, in some ways, think of distributing the power of 2 to both the 1/3 and to the x. So I would have 1/3 squared is 1/9. X squared is x squared minus 2. So you can see that we do end up with a parabola. It has you could say it has a vertical shrink or vertical compression by 1/9, and it shifted down 2. And that's what we saw in Sketchpad as well. Okay, last example for this video. If x were to equal 2 times cosine of t, y equals 2 times sine of t, and we're looking at this interval from 0 to 2 pi, what kind of picture would we have? Well, this is going to be quite difficult unless we have an idea of what the picture looks like. So again, we go back to Sketchpad, have it all set up for us. We're going from 0 to 6, or 0 to about 2 pi, and I hit advance, and you see that we are getting a circle. It's centered at 0, 0, and it looks like it has a radius of 2. So we almost need to have that picture first to maybe understand what this is going to look like. So we'll need a little quick refresher here. Do remember that x squared plus y squared equals r squared is our equation for a circle centered at 0, 0. So I'm going to start, this is going to look very different than the other ones. I'm not going to take one of these equations and solve for t. I'm going to start with x squared plus y squared. And I'm just going to do some substituting and hopefully get something that makes sense with this radius being squared in the long run. So x was 2 cosine of t, and that's being squared. Okay, y was 2 sine of t, also being squared. And then I'm going to kind of do that distributive idea again. 2 squared is 4. And then the cosine of t being squared, I could write like this. Sine is going to be very similar. So far nothing obvious, but what I do notice is that both of these things have a 4 in the front, so I'm going to factor out that 4. I'm left with cosine squared plus a sine squared. And if you remember from previous units in this semester, cosine squared plus sine squared, as long as you have the same variable there, that equals 1. So really I'm left with 4 times a 1, or just 4. And if I go back to what I'm trying to make this equal to, I want x squared plus y squared to equal the radius squared. I started with x squared plus y squared. I know what it equals 4. Really, that's 2 squared. And so I've just shown that using this idea that we have right here of what x equals what y equals, that x squared plus y squared equals 2 squared, which fits a circle with a radius of 2, which again is what we saw in our picture right there. Okay, so just 3 kind of quick examples. None of them are necessarily super easy, but just giving you something else to think about. And you can see when we're in class, way down here I have all kinds of extra ones that I want to show you. Just some really cool, unique pictures that we can come up with using these parametric equations.